Welcome everyone, we are the UPC01 group and we are representing the Peruvian University of Applied Sciences from Lima, Peru. In this opportunity we will show you how the innovating use of existing technology could improve the construction communities with an overall reduction of the global impacts caused by the current concrete constructions. My name is Anngie Rojas and all of us are going to talk about the application of BioConcrete to mitigate cracks in structures. At the Technical University of Delft in the Netherlands, they have developed BioConcrete, a material that is literally alive and that can regenerate the wear of buildings. Our concrete is gonna revolutionize the way we build, because we are inspired by nature, said John Kurtz when he was nominated for the European Award for Best Inventor in 2050. But more than inspired by nature, the BioConcrete is composed of it. It is for this reason that our group believes that this technology can revolutionize the world.
One of the main problems that currently exist in concrete construction is the presence of fissures. As can be seen in the graph, 21% of the most common pathological problems in concrete belong to active or passive fissures. The appearance of these fissures are very common and can be caused by errors at the moment of carrying out the construction process, errors at the moment of carrying out the design, or errors when not considering the climatic conditions in which the concrete will be poured. One of the fissures that can appear when the concrete is in a plastic state is the fissure by plastic contraction. Such fissures occur when the concrete is exposed to a rapid loss of moisture caused by the temperature of the concrete and the temperature of the location where it will be used. This happens in different sides of the world, where there are cities with very high or very low temperatures. It is worth mentioning that Peru is a country that has departments with very different thermal gradients for extreme heat to extreme cold, which can represent a great challenge for engineers when calculating the correct dosage of aggregates and additives to meet the requirements needed to make a correct pour according to the conditions where the concrete will be used.
The BioConcrete is an innovative aims to improve the mechanical properties of a conventional concrete, turning it into a concrete that repairs itself by biological agents. The bacteria that is introduced in the manufacture of this innovative material has a useful life of approximately 200 years in concrete, which provides a greater benefit for the structures. This is how one of the smallest beings on the planet can be a fundamental part of the most important construction that man can design. But how does it work? Well, when it rains, the water penetrates the small cracks and reaches the concrete iron and oxidizes. The BioConcrete has in its mixtures bacteria that act as an extra repair agent. It activates when the water enters into the cracks. Well, these bacteria are inactive while the concrete is dry, but they are activated when the concrete is filtered with water. The bacteria added to the concrete mixture in calcium lactate capsules. Once in contact with water, the bacteria would feed on their capsules producing limestones, which would fill the cracks or fractures produced in concrete. So now we are witnesses about how the technology can improve all the constructions in the world.
First of all, I would like to give you an overview of Bacillus pseudophilus. This bacillus belongs to the alkalinophilic species. They are able to survive in an alkaline environment with a potential of hydrogen elevated. Also, Bacillus pseudophilus can withstand the extreme concrete environment due to endospheres. In addition, the habitats of these bacteria are hostile environments such as active volcano craters, and they need a minimum potential of hydrogen of 9.7 to grow. Since they are gram-positive bacteria, they are compatible with urease. Bacillus pseudophilus attaches directly to concrete through a mechanism of metabolic conversion to organic acid. The nutrients that have been used to produce calcium carbonate in the concrete body are calcium lactate, calcium acetate, yeast extract, and peptone. The graph shows the regeneration process of two cracks 100 days after the activation of the bacteria. As we may know the life cycle of building products ends in the demolition stage, generating waste and affecting the environment. From this, BioConcrete differs from conventional concrete, being a concrete with self-generating characteristics and high resistance. It has been shown to be a type of concrete that is friendly to the environment due to low impact on water pollution, allows reducing CO2 emissions, and with its prolonged use, it tends to reduce concrete waste produced by the demolition and restoration of concrete structures.
These are some of the papers that we have used to understand more about the subject. BioConcrete is 37.5% more expensive than the traditional concrete, but in long-term conditions it is profitable as it reduces maintenance costs. The greatest amount of repair expenses are due to the cracks that appears during the useful period of the concrete. In this way, having technology avoids incurring expensive time losses and the discomfort to resident in their properties. Thank you.